The sinking of the Titanic in 1912 left behind a mystery that would take over 7 decades to solve. Although the ship sent out distress signals with coordinates that allowed the Carpathia to rescue hundreds of survivors, the actual wreckage remained hidden nearly 2.5 miles below the surface of the Atlantic Ocean. Early attempts to locate the ship faced insurmountable challenges, because technology at the time could not reach such extreme depths. Some early ideas included using dynamite to dislodge bodies, but these were quickly dismissed. It was not until the development of sonar and submersibles following 2 world wars that serious expeditions could begin in 1953. Riston Beasley tried using explosives to create sonar echoes, but the method was too crude to provide useful maps of the ocean floor. Even with the coordinates provided by the crew, the search area was vast because the ship could have drifted significantly as it sank into the dark abyss where currents were unpredictable, and light never reached the vastness of the sea floor, made searching for a single point almost impossible during those early years of exploration, when underwater technology was still in its infancy. In the late 1970s, Robert Ballard and later Jack Grimm took up the challenge of finding the famous wreck. Jack Grimm was a wealthy oil tycoon known for funding searches for the unknown, including Bigfoot and Noah's Ark. He collaborated with scientists, but brought his own eccentricities, such as claiming a trained monkey could help locate the ship. Despite the odd circumstances, the team used side-looking sonar to sweep the seabed searching for metal objects. Unusual shapes. They realized the original coordinates might be wrong because the first officer had not accounted for a time change during the voyage. This meant the search area had to be expanded into a massive rectangle covering hundreds of square miles. Despite their best efforts and the use of magnetometers to detect man-made structures, they returned empty-handed, but their failure provided valuable lessons for future explorers who would eventually entire search strategy by focusing on the debris rather than the hull itself, because finding a trail was more likely than finding the main structure in the complete darkness of the deep sea, where visibility is limited to a few meters. Robert Ballard eventually secured support from the US Navy by agreeing to locate 2 lost nuclear submarines, the Thresher and the Scorpion, during the Cold War. While mapping these wrecks, Ballard noticed that they created long trails of debris across the ocean floor known as Comet trails. He theorized that the Titanic would also have a massive debris field, and that finding this field would be much easier than finding the ship itself. In 1985, Ballard used a new tool called Argo, which was a towed sled equipped with cameras providing live video feed for the first time as the deadline for his mission approached. The team began to see signs of man-made objects on their monitors. On September 1, 1985, a massive boiler appeared on the screen confirming they had finally located the Titanic. The ship was found in 2 main pieces with the bow and stern separated by a large distance. The discovery, triumph of technology and persistence, proving that the debris field method was the key to unlocking the secrets of the deep and providing a final resting place for the legendary vessel which had remained hidden for 73 years. After the initial discovery, the crew spent time mapping the area and realized that the wreckage was divided into 2 main sections, the bow and the stern, which were separated by a large debris field. This discovery confirmed that the ship had indeed broken apart on the surface before sinking, which was a point of debate for many years. The bow section was found to be in remarkably good condition, while the stern was severely mangled due to the air trapped inside causing it to implode during the descent. The team found iconic parts of the ship, such as the railings and the anchor chain, still in place, looking as if they were frozen in time. The sheer scale of the debris field, which stretched for miles, showed the violence of the sinking process, with countless personal items and pieces of the ship scattered across the ocean floor, including plates and cups, and even shoes that remain as a haunting reminder of the passengers who were on board. This success brought worldwide fame to Robert Ballard and his team, but it also sparked a long and controversial debate about whether the site should be treated as a mass grave or explored for historical artifacts and profit. Today, the wreckage remains a site of immense scientific interest, as researchers study the bacteria that are slowly consuming the metal hull, and predicting that the ship may eventually disappear entirely into the ocean floor within a few decades. Current rate of decay continues to progress at its current pace. In the years following the discovery, interest shifted from just looking at the ship to bringing parts of it back to the surface. In 1996, a major expedition was launched to recover a large section of the hull known as the Big Piece. This mission was turned into a massive media event, with cruise ships full of tourists and survivors watching from above as deep-sea submersibles attached lift bags to the massive metal plate as the piece was being pulled to the surface. Weather turned bad with Hurricane Edward approaching the area, bringing high waves and dangerous winds. The strain on the lifting equipment became too much, and the cables eventually snapped, sending the heavy section of the hull sinking back down to the bottom. In front of the horrified witnesses, it would take 2 more years and another mission to finally bring that piece to the surface where it could be preserved and displayed for the public to see. This event showed the extreme difficulty of recovering objects from such a great depth and the unpredictable nature of the Atlantic Ocean. Despite this specific failure, many other smaller items have been successfully brought to the surface, including jewelry and currency, and even large portions of the grand staircase that provide a glimpse into the luxury that once existed on board the ship. This mission demonstrated that while the sea is a harsh master, the human desire to connect with history often stronger than the obstacles placed in our path, as we continue to push the limits of what is possible in the deep sea, with more advanced robots and sonar mapping tools that were once thought to be science fiction. The recovery of artifacts from the Titanic remains a sensitive topic, with many explorers and descendants of survivors arguing that the wreckage should be left in peace, as a memorial to the 1,500 people who died. Others believe that by recovering and preserving pieces of the ship, we can keep the memory of the Titanic alive for future generations. This story of the search for the ship is not just about finding a wreck, but also about the incredible progress in underwater technology, from crude explosives and early sonar to the high-definition cameras and remote submersibles used today. The methods developed by pioneers like Ballard have since been used to find other lost ships, and even nuclear submarines, providing valuable insights into our history and the deep-sea environment. The Titanic continues to be a symbol of human ambition, and the power of nature, serving as a reminder of the risks involved in pushing the boundaries of technology and exploration across the vast and mysterious oceans of our world. The legacy of the Titanic is not just one of tragedy, but also one of discovery and the constant drive to uncover the truth about our past. No matter how deep it is buried, for many the ship remains the ultimate symbol of the industrial age and its end, while for others it is a lesson in humility and the need for better safety standards in modern travel. As we look back on the century since it sank, the lessons learned from the Titanic continue to influence engineering and maritime law, ensuring that such a disaster is never repeated in the same way again. While the ship itself may fade, the story will undoubtedly live on through the efforts of those who refuse to let it be forgotten in the darkness of the deep sea. Focusing on the technical difficulties of the 1996 mission, the recovery of the big piece was hampered by the arrival of Hurricane Edward, which created a high-pressure environment for the crew. They had to balance the desire to make history with the safety of the vessels, and the people on board. The piece was a 20-ton section of the hull that had fallen from the ship as it broke apart during the sinking process. When the cables snapped, it was a devastating blow to the team, but it also highlighted the sheer power of the ocean currents and the unpredictability of deep-sea salvage operations. Researchers have since used the data gathered during these missions to better understand the structural integrity of the ship and how it reacted to the immense pressure as it descended to the seafloor. Today, we have highly detailed three-dimensional maps of the entire site, allowing us to study every inch of the wreckage without ever leaving the surface, which is a testament to how far we have come since Ballard first saw the boiler on his monitor in 1985. The mapping technology has advanced from grainy black and white photos to photogrammetry that creates a digital twin of the wreckage for future study. Scientific studies conducted over the last few decades have revealed that the Titanic is being consumed by a unique species of rust-eating bacteria known as Halomonas titanici. These microorganisms are slowly turning the iron hull into fragile structures called rusticles, which eventually collapse and turn into fine dust. This biological process means that the ship is effectively returning to nature, and many experts predict that the upper deck's iconic bow railing will collapse within the next few years. The realization that the wreck is disappearing has increased the urgency for high-resolution digital documentation. In 2022, mission captured the first-ever 8K video of the wreckage, providing unprecedented detail of the bow anchors and the cargo hold. This digital preservation ensures that even after the physical ship has crumbled away into a pile of rust on the ocean floor, its legacy, the lessons it taught us about safety and engineering, will remain accessible to historians and the general public forever. The story of the Titanic search and its eventual discovery remains one of the greatest maritime adventures in human history, combining high-stakes science and the pursuit of truth. While the metal may fade, the stories of those who sailed on her and those who found her will endure. This fascinating story of the raising of the Titanic and the challenges faced by explorers is part of a larger series titled Underexposure, which explores ambitious and high-budget documentaries about significant historical events. Besides the Titanic, there are deep dives into other major incidents such as the disaster at Tenerife, which remains the worst aviation accident in history, and the detailed account of the US military raid on the Bin Laden compound. These films are created with a focus on cinematic storytelling and historical accuracy, rather than following simple trends or algorithms. By focusing on the human element and the technical details that are often overlooked, these documentaries provide a comprehensive look at the events that shaped our world. They are hosted on Nebula, a creator-owned streaming platform where artists and historians can produce content that requires more time, resources than typical web videos. This allows for a more immersive experience for viewers who want to understand the complexities of the past and the incredible efforts required to uncover long-buried secrets like those of the Titanic, which continues to captivate the imagination of people across the globe. Even more than a century after it disappeared, the pursuit of knowledge requires dedication and the courage to look where others have not. The 1996 mission to raise a portion of the hull was designed as a massive media event, with thousands of onlookers witnessing the struggle between man and the ocean deep within the North Atlantic. The technical team utilized specialized lift bags and remotely operated vehicles to secure the massive piece of steel, but the operation was plagued by mechanical issues and the sudden arrival of a powerful hurricane. The extreme waves and wind created by Hurricane Edward made it impossible for the surface ships to maintain their positions, leading to the snapping of the heavy cables. This failure was a significant setback, and a blow to the ambition of recovering large-scale parts of the ship for public display. The event demonstrated that even with modern technology, the deep ocean remains a dangerous and unpredictable environment that can easily destroy the most carefully planned missions. This attempt also raised questions about the ethics of such salvage operations and whether the focus on spectacle was appropriate for a site that represents such a massive loss of human life and historical tragedy. As the years pass, the physical remains of the Titanic are undergoing a slow but inevitable transformation due to the presence of unique bacteria that consume the iron structure. This biological decay has created a sense of urgency among those who wish to document the site before it is gone forever. High-resolution imagery and laser scanning are now being used to create permanent digital archives that will allow future generations to explore the virtual reality even after the metal has collapsed into dust. This shift from physical salvage to digital preservation represents a new era in underwater archaeology, where the focus is on gathering data rather than removing artifacts. The ongoing debate over the site reminds us of the dual nature of the wreckage as both a scientific laboratory and a mass grave. Balancing these perspectives requires a careful approach that respects the dead while still seeking to understand the events that led to the tragedy. The legacy of the search for the ship is a story of persistence and innovation that has pushed the boundaries of what is possible in deep-sea exploration and continues to inspire millions of people around the world today. The search for the Titanic and the recovery efforts that followed are part of a rich history of exploration that is documented in the series Under Exposure. This series focuses on providing a detailed and cinematic look at major historical events and technical challenges that have defined the modern world, from aviation disasters to military operations. The documentaries explore the human element and the complex engineering behind these events. These projects are part of a growing movement of independent educational content that prioritizes depth and accuracy over simple entertainment. By utilizing platforms like Nebula, creators can share their most ambitious work with an audience that values high-quality storytelling and thorough research. The journey of the Titanic, from its tragic sinking to its discovery, and the ongoing efforts to preserve its memory, is a powerful example of the enduring human spirit and our constant desire to uncover the truth about our history. The lessons learned from the ship and the missions to find it will continue to influence science and culture for many years to come as we continue to explore the final frontiers of our planet and beyond its vast oceans. Argo was a revolutionary deep-sea exploration vehicle that changed how scientists view the ocean floor. Unlike previous tools that relied solely on sonar, Argo provided real-time video feeds allowing for immediate identification of debris. This transition was crucial because sonar alone often produced ambiguous shapes that could be mistaken for natural features. Ballard used Argo to scan the seabed for signs of human activity rather than just the large hull of the ship. This method proved successful when the team spotted a boiler, which was a clear indicator that they were close to the main wreckage site. The success of Argo paved the way for more advanced remotely operated vehicles and autonomous underwater vehicles that are now used in scientific research and commercial operations. The ability to see the deep ocean in such detail has opened up new possibilities for understanding marine biology and geology in some of the most remote and extreme environments on our planet. Through the use of high-definition cameras and powerful lighting systems, we can now explore depths that were once thought to be completely inaccessible to human eyes. The collaboration between the American and French teams was essential for the eventual discovery of the Titanic wreckage. Jean-Louis Mitchell and his team from IFREMER used a sophisticated side-scan sonar to map a wide area of the ocean floor. While the process was slow and methodical, it narrowed down the possible locations of the ship. The two teams used a technique known as mowing the lawn, which involved towing sensors back and forth in straight overlapping lines. Ensure complete coverage of the survey area despite the challenges of ocean currents and limited visibility. Their combined efforts eventually led to the precise coordinates of the wreckage. This partnership highlighted the importance of international cooperation in large-scale scientific projects. The data collected during these missions has been used to create the most accurate maps of the Titanic wreck site ever made, providing a valuable resource for future explorers and researchers. The success of this mission showed that combining different technologies and expertise can overcome even the most difficult challenges in the pursuit of knowledge and discovery. Beyond the technological achievements, the discovery of the Titanic led to significant changes in international maritime law and the protection of historical sites in the deep sea. The site is now recognized as a memorial, and efforts have been made to regulate salvage operations to ensure the wreckage is treated with respect and dignity. The discovery also prompted improvements in ship design and safety regulations, as the tragedy of the sinking became a case study for maritime engineering. The lessons learned from the failure of the ship's bulkheads and the lack of lifeboats have influenced modern shipping standards for over a century. Today, the Titanic serves as a reminder of the need for constant vigilance and the importance of learning from past mistakes. The ongoing interest in the wreck reflects our enduring fascination with the sea and the stories of the people who traveled across it. Through careful study and documentation, we can continue to honor the memory of those who were lost while expanding our understanding of the deep ocean and its secrets. The legacy of the search for the Titanic remains a powerful example of human curiosity and the drive to explore the unknown even in the face of overwhelming odds.